Liming returns as climate and yield strategy. A traditional agricultural method, liming, may be key to addressing both food security and climate goals, according to new research out of Georgia Tech. The process, which involves applying crushed limestone to correct soil acidity, has long been used to improve crop performance. But its overlooked potential to remove carbon dioxide from the atmosphere is now gaining traction with researchers, agribusinesses, and supply chain leaders. Far from being just a soil amendment, liming is proving to be a dual-purpose tool, enhancing crop yields while contributing to verified emissions reductions. That's a rare combination in climate-smart agriculture, particularly for regions like sub-Saharan Africa, where degraded soils cost billions annually in lost productivity. This positions liming as a high-impact, lower-cost intervention for agricultural producers, food processors, and corporate sustainability teams. As pressure increases for measurable Scope 3 emissions reductions and nature-based solutions, liming presents a practical, data-backed opportunity. Data-driven models unlock commercial potential. What sets this new phase of liming apart is the role of advanced analytics. Research partnerships across the U.S., including trials in southern Georgia, North Carolina, and the Corn Belt, are using precision data collection to map variables like soil pH, nutrient levels, trace elements, and greenhouse gas fluxes. These inputs are feeding machine learning models that can forecast how liming will impact both productivity and emissions under specific soil, crop, and climate scenarios. One of the key breakthroughs: not all liming leads to carbon removal, and the net climate impact depends on timing, soil chemistry, and other conditions. For ag tech firms and consultants, this opens the door to tailored liming recommendations and precision tools that drive both agronomic and environmental outcomes. Because many farms already collect relevant soil and crop data, implementing enhanced liming strategies doesn't require expensive new infrastructure, lowering barriers to entry and accelerating adoption. There's also a clear path to monetization. With growing interest from voluntary carbon markets and regulatory bodies, verified liming practices could qualify for credits tied to CO2, methane, and nitrous oxide reductions. For businesses managing agricultural supply chains, that means potential for cost savings, revenue generation, and stronger ESG reporting, all from an existing farm input.